Back to another video, guys. This is all about combined questions dedicated to trigonometry. The level is medium one, so for some from year 9 students it might be hard problems. So make sure you understand how to work with sine and cos rule because it's really significant. You also need to remember that you are able to apply circle theorems, all right, because that's combined with that, and also similar triangles. All right, let's move to the problem 4. So in previous one we discussed problem 1, problem 2, and problem 3, so make sure you watch them all because that's definitely year 9 really nice demonstrations what sort of problems you might meet on your exams. So here is the problem 4. You are given a circle, you're given several segments, so make sure you understand and be able to answer those questions. All right, pause the video, try to do by your own, and here is my explanations. All right, so first we need to prove that triangle BCF and FDA are similar. So similar means not equivalent, but they do have all angles the same, right? So that means they basically one triangle is obtained by scaling. So for example, triangle FDA is bigger than triangle BCF. So that's why BCF can be obtained by scaling down the biggest triangle with some scale factor. We don't care about which factor, we are not asked about that. We just need to prove why they're similar. All right, so let's get proof that. So first of all, let's have a look at angle F. So they're vertically opposite, and that's why they're equal. Okay, so what about angle, for example, angle B and angle A? If you have a look at those two angles, you will notice that they both have points C and D, and basically they're subtended by the same arc CD. So that's why you can say that angle B is equivalent to angle A because they subtend or they subtended by the same arc length. So arc, by the same arc CD. So in this case, it's mine arc all along this way. Okay, so they are both inscribed angles, and that's why they're equal. Okay, so we proved that two angles are respectively equal to two other angles in the biggest triangles. So that means automatically that angle C and D, they're also equivalent to each other. So that's the proof for A. So that was A. So what about B? You're given the ratio CF to BF, and the area of triangle BCF is 120, and the size of the angle CFB is 28 degrees. So let's put 28 degrees right there, and let's consider triangle BCF because we're given the area for that. Okay, so which way we can complete the equation in order to find sides BC and CF? So we definitely need to consider CF and BF. Let's consider triangle BCF, and let's complete the ratio CF to BF. Okay, so we need to find the side BC. Let's try to do that. So if we mark side BF as x, from this ratio we can express CF over x, because we mark BF as x, as 3 over 4. So from there we can conclude that CF is 3 over 4 of x. So we can put 3 over 4 of x right there. Okay, so 3 over 4 of x. So that's side CF. And now we are given both sides x and x. We are given their angle 28 degrees. So what we can do, we can complete the area, right? Let me see. So we're not given BC, we can figure out through x, and C we can figure out, yes, through the area. All right, let's do that. So cos rule from the triangle BCF, using cos rule, we can complete that BC squared is simply x squared plus 3 over 4x squared minus 2 times x times 3 over 4x and times cos 28 degrees. Okay, so that's the first equation. However, we are not given x when we are not be able to calculate the value for BC. So that's why if we can complete the area of the triangle BCF, equation for the area, so I hope we will do that. So area of the triangle, using the shortcuts through the sine, so the formula using the sine, 1 over 2, two sides, x times 3 over 4x, and times sine of the angle 28 between them. All right, so instead of using height, we can do that. Previous video I already you already shown that. And because the area is 120, we can simply say that, okay, so this is 120 centimeters squared. We can put 120 and we can figure out x. Let's do that. Let's simplify. 120 equals to 1 over 2, 3 over 8, 3 over 4. So that means 3 over 8 x squared and sine 28 degrees. If you want, you can calculate on the go, but I would like to just express angle x as square root of 120 times 8 and over 3 times sine of the angle 28 degrees. Okay, so that's the value for x. If you want, you can calculate right now, because we're definitely sure, or we need to do that right now. Square root of 120 times 8 and over 3 times sine 28 degrees. So that one, and finally this one. So what I've got 26.11 to 2 decimal place. So 26.11 to 2 decimal place. So that was BF. So we found BF. So that means we can plug into the formula and calculate first BC and then CF. Okay, so because CF we also need to calculate, let's calculate that CF first. 3 over 4 of that, so we multiply by 3 over 4, which is 0.75. Okay, and you'll get around 19.58. 19.58. So that's our CF. So we answered part B. For CF, we calculate the value centimeters. So x, that was BF, but we need to find BC. So that's why right now we just plug there. So this is x. We already know that's 26.11. Just now we using the previous formula from cos theorem and just try to work out the value for BC. Okay, so it's square root of x squared. That means 26.11 squared. Then we add 3 over 4x squared, but this is 19.58 squared. Then we subtract 2 times 26.11 times 19.58 and times cos of the angle 28 degrees. Cos 28 between them. Okay, so what I've got BC equal to 12.74 centimeters. So let's recap. So we've got BC, it's right there, and we've got CF, which is right here. Okay, so we've got all the values, and now let's go to C part. So in C part, if sine FD from here to here, it's 40 centimeters. What is the length of side AD? So we need to figure out that side. Let's put the value of y for the length of DA segment. Okay, so this is y, this is 40, and I'm pretty sure we can use the idea of proportional sides. Okay, so triangles we consider in C, so triangles BCF is similar to triangle AFD. So that means we can complete the proportional sides ratio. Okay, but hold on, be careful with that, because so this angle is that angle. Okay, so that means if how to make them similar so that you can see what's proportional side you need to use. Okay, so if you start from the biggest side, FD is going to be proportional to CF. So I just mark that FD over CF, so we're taking corresponding sides, right, is the same as DA, which is the base. In this case, it's Y over BC. Okay, so from where we can plug the values. So we know FD is 40, CF it was previously found. So CF is 19.58, it's right there. So 19.58, and on the right side, so DA, it's Y over BC, that we also found it. BC is 12.74, so 12.74. All right, so from there we can express Y. It's simple ratio that we can resolve pretty easy. Crisscross multiplication. 1274 we times 40, and we divide by 19.58. And now what's left is just to calculate that. 40 times 12.74, and we divide by 19.58. So we've got the answer. It's 26.03 to 2 decimal place. That was unknown side length DA. So this is DA side, and this problem is done. Hope you like those combined questions. I think it's pretty useful when prepared for your examinations. Not really final, it can be used whenever within the topic you are in. So I hope you like that. Don't forget to subscribe if you're new here. I'm also planning to continue physics topics, so that's a bit higher level, but it will be definitely interesting for you guys. That was Daniel Dallas, and peace out.